Draw a diagram to show that there are two tangent lines to the parabola y equals x squared that pass through the point 0, -4. Find the coordinates of the point where those tangent lines intersect the parabola. Okay, so let's take a look at this. So, how many people were you able to make a picture, Hutch?
Yes, I made a picture.
Cool. So logically, does it make sense?
Yes.
Okay. So now you're just trying to look at what, the algebra, or how to slog through it? Sure. So we have y equals x squared. Show that there are two tangent lines that pass through 0, -4. So I'll extend this down a little bit further. When you draw these tangents, so 0, -4 right about here, so one of these tangent lines will look like this. What do you know about the relationship between this first tangent line, we'll call this tangent line 1, and the other tangent line?
They have the same slope, except it's negative. One has a negative.
So one's going to be negative.
Yeah.
So if this one's like +3, the other one's going to be -3. That seems like a safe assumption. We haven't proved that. We need to know something, but that seems like a good assumption. Okay, so what is it asking you to find? It's asking you to find the coordinates of the points where these tangent lines intersect the parabola. So you're trying to find this coordinate and this coordinate. If you found this coordinate, what have you also found?
The other one.
It seems like you'd also find the other one, right? It seems like it would be it's an even graph. It's symmetric across the y-axis. Okay, so we know what this coordinate is, right? 0, -4. Do we have any idea what this coordinate is right here?
Nope.
No, so let's call it what? X, comma, y. Or better yet, let's just pick something that isn't already there. How about AB? If we find the values for A and B, are we pretty golden?
Yep.
What is the slope between 2 points? How do you find it? We'll call this point A, and we'll call this point B right here. If I wanted to find the slope from A to B, it's the change in what?
Y over the change in x.
Change in y. So B minus what?
-4.
Over A minus
0.
A minus 0. So the slope from A to B is going to be B plus 4 over
A.
A. So we know the slope from A to B is B plus 4 over A. We just wrote that. Do we use derivatives at all to find that?
No.
No.
No. Okay. This function right here, what is the function? It's y equals
X squared.
x squared. So what does y prime equal?
X.
2x. Y prime equals 2x. Again, what's this coordinate?
A, B,
What's the x value at that coordinate?
A.
A. So what is f prime at A?
2A.
2a. What else do we have? We have the slope from A to B. What is this also equal to? F prime at A. Do you agree with that? We found the slope of the tangent how many ways? 2 ways. We evaluated the derivative at A, and we also found the slope between 2 points. Are we okay so far?
Yeah.
So if we know that f prime of A is 2a and f prime of A is b plus 4 over a, what can we say? 2a is equal to what?
B plus 4 over A.
b plus 4 over a. Do we already? So this is one equation and how many variables? 2 variables. So we need another equation. Do we have a relationship between a and b? Yeah. AB is on the parabola what?
X squared.
Y equals x squared. So if AB is on the parabola y equals x squared, what does b equal? B equals what? Since AB is on y equals x squared. So what can we do with this? Where do we put that?
In for B.
In for B. So 2a is equal to a squared plus 4 over a. So therefore 2a squared is equal to a squared plus 4. So a squared is equal to what? A squared is equal to what? 4. Yep. So a is equal to plus or minus 2. Did we expect to get 2 answers for a?
Yeah.
Yeah, so we therefore know that this is 2. And what's the y value? 4. And therefore this one is -2 and 4. Exactly. Good. Done. Write 2 different equations for the slope. One using the derivative, one using slope between 2 points. Yeah, absolutely. Find the cubic function. So it's y equals ax cubed plus bx squared plus cx plus d, whose graph has horizontal tangents at, so horizontal tangents at -2, 6 and 2, 0. What does a horizontal tangent mean? What happens if a horizontal tangent is there? What does that mean?
It means the derivative.
The derivative
Zero.
evaluated at that
Point
x
equals
at that x
zero.
value equals 0. So what's the derivative of this function? What is f prime of x going to be? 3ax squared plus c. And you know when you plug in -2, what should you get out? 0. So you know that f prime of -2 has to be 0. No. The function evaluated at -2 is 6. The derivative evaluated at -2 is
0.
So therefore you know that so 0 is going to be equal to 3a times -2 squared plus 2b times plus c. And we also know that f prime of has to be, so that's going to be 3a times 2 squared plus 2b times 2 plus. Okay, so how many equations do we now have? How many variables do we have?
3.
3. We do not have enough information to solve, unless there's some cute thing going on, but there isn't. But we also know, as Maddie pointed out, when x is -2, what does y have to be in the original function? 6. And when x is 2, what does y have to be? 0. So let's actually use this one right here, and so therefore we know that 0 has to be 2 cubed plus b times 2 plus c times plus d. And we also know that when you plug in, you get out 6 when you plug in a times -2 cubed plus b times -2 squared plus c times -2 plus d. How many more equations did we just generate?
2.
How many equations total do we have?
4.
How many variables do we need to solve for?
4.
Am I going to slog through the algebra right now? No. No. You can, ready? Slog on your own. Did that answer your question about how to do this question? Yeah, there's one there. Theoretically, if you do this right, you should have some nice answer. Theoretically, I don't know what it is off the top of my head. Okay, we're good. Actually, I can tell you. Hold on. No, I can find it. I can product and quotient rules. That's right. You got it. On last night's homework, what happened if you had to find the derivative of the product of two things?
You
What-
had to make one a negative. Well, you had to make the denominator negative and bring it into the numerator.
Well, no, not if
Oh,
it was a
the
quotient. I'm
product.
sorry. What happens if you had
You
two
had to
things?
distribute.
You had to distribute it out and make it into not a product, essentially, right? Are these rules what you think they would be if you'd never seen them before? What do you think?
No.
It's a leading question. No, they're not. Okay? No, they are not. Okay? No, no, no. So let's just get this out of the way. If I had f of x times g of x, and I said, what's the derivative of that function? Can someone tell me what it is not equal to?
The derivative of f of x times
No. 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 No, no, no. No. And you actually can already kind of figure this out. Let me clip it in here. Let's try this out. So if I gave you a set of functions here, f of x and
g of x.
g of x. You can already use the logic you know to disprove this. At least give one example. Is one example enough? Yeah, well, f of x is 2x, so you know that the derivative is x squared. The derivative of x squared is 2x. The derivative of x is
1.
1. That's great. What does that mean? What is f prime of x times g prime of x going to be?
2x.
2x. What is f of x times g of x equal to? X cubed. What is the derivative as we know it of x cubed? So what did we just show? 3x squared does not equal 2x. So there's one straightforward example for you. Can you just do that? No. 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 We're using the limit definition of derivative. That's fine. F of x plus h, g of x minus that, right? So here's the thing. You get to this and you think, what the heck am I supposed to do? This is one of my favorite maneuvers in all of math. The random pull something out of absolutely nowhere trick, which if you do it enough, this becomes not so random. Like you will see this maneuver. If you add and subtract the same thing do you still have a true statement?
Yeah.
Generally speaking, so, and you actually do that. When you're balancing equations, you add 4 to both sides. Sometimes that helps. When you're completing the square, you add the same thing to both sides. In this case, look what happened here. You see this? There's a new term here. What was added in? Like what? Oh, that's not the right button. What was? I'll clip this in. That's not what I wanted. What was added and subtracted here? Take a look at it real closely. We're gonna look at this one step. Something was added in and subtracted at the same time. Yeah. See this right here? If we subtract and add the same thing, are we okay?
Yeah.
Yeah, okay, so we did that, and the question is, why? Why would we do that? Well, we do that because, take a look, if we do this, you can break this apart into 2 limits. We can break it apart into 2 limits, keep on working on this, distribute, kind of quote unquote distribute the limits in. Well, what is the limit as h approaches 0 of this right here? What is that? That is g prime. What is the limit as h approaches 0 of this thing right here? That is f prime. So you have the limit as h goes to 0 of f of x plus h. What is that? F of x. What's the limit as h goes to 0 of g of x? G of x, there's no h in it, right? So what do you have here? You have f of x, g prime, g of x, f prime. What you've just proven is this. You've proven that the derivative of f times g is fg prime plus g f prime. Let's make that nice and big. This right here is the product rule. Are you expected to be able to prove the product rule? No.
I hope not.
It's actually not that bad. It's that random step you'd have to remember that allows you to factor. And the reason that comes up is whoever was the first person to write this down, was it a completely linear work? Did they start? No. They looked at where they wanted to end it up and what they suspected, and they met in the middle. They realized, oh, if I add in some, oh, now it works. This right here you will use all the time. The derivative of f times g is f g prime plus g f prime. All you have to remember is that this is a plus, and then it's g times the derivative of f and f times the derivative of g. Does it matter if you switch the order of these right here?
No.
No. Does it matter if you make it g prime f and f prime g? No. Totally burn it into your memory as one method and then just use that. For me, I always do f prime g, g prime f, but it totally doesn't matter as long as you make it plus. As long as you make it plus. If you change it to minus, bad things. This one actually, right? Yeah. So it's 1 times what? Plus
X times e to the
x times e to the x. So this comes down to e to the x plus x e to the x. So you might see it written as what instead? E to the x times, yeah, like 1 plus x, yeah, or x plus 1. That's what you might see. Are those two of your favorite nice, clean derivatives? Sure.
Yeah.
Yeah, it is kind of nice. Now what about this right here?
The not so nice derivative.
This one right here. Well, it's not as bad. You know the rules. You can definitely do this one. Absolutely. What's the first function?
Square root of
T. Second function, 1 minus t. So in this case, Fitz, what would it be? F prime of t is?
1/2 t
To the
negative 1/2.
times 1 minus t plus the square root of t times what?
0.
What's the derivative of that? What is it?
1.
Negative 1. It's negative 1, right? Now, if I gave you this last night, how would you have done it if you did it last night?
factored it out.
Not factored it. You would have distributed it out. So what do you end up with? F of t is the square root of t minus what? T to the 3 over 2. If we do the derivative this way, you end up with 1/2 t to the negative 1/2 minus 3 over 2 t to the 1/2. Now that and that, do they look the same? Maybe. Should they be the exact same? Sure, yeah. If we do the algebra, they will be the exact same. So are there going to be some of these that are multiple methods will work? Absolutely. Is one of them generally the quickest, easiest method?
Yeah.
Yeah. It's debatable which one is the quickest, easiest method here. Debatable. You end up with a similar amount of work. Now what about this one right here? Well, no, we're not to the quotient rule yet. We're not to the quotient rule quite yet. I want you to do one more of these. If I gave you this right here. If I said f of x is g of x times the square root of x, where g of 4 is 2 and g prime of 4 is 3. Find f prime of 4. F prime of 4 means find the derivative of f and plug in 4. So, Maddie, could you tell me what is the derivative of f, just looking at this? Yep. It's
Okay, so it would be 1/2 g of x.
So yeah, 1/2 what?
G of x.
No, okay, I want you to be careful about how you communicate this. Here's the first function, here's the second
Oh,
function.
okay, 1/2 times x
To the
1/2
negative 1/2 times.
times
Yep, exactly. Plus what? What's the derivative? What's the other function? G prime of x times what?
square root of x.
Yeah, exactly. So if you wanted f prime of 4, what does that equal? 1/2 times 4 to the negative 1/2 times g of plus g prime of 4 times square root of 4. What is 1/2? What's 4 to the negative 1/2? It's 1 over the square root of 4, which is? So that's going to be 1/2 squared. What's g of 4? Oh, does it tell you g of 4? What's g of 4?
3.
2.
Oh.
What's g prime of 4?
3.
And the square root of 4? So this equals 1/2 plus. So it's going to be 13 over 2. Do you have to know the function itself? No, they could give you the exact values you need. This type of question is absolutely something you could see on the AP exam. Absolutely. There's no trick to it other than, do you know the product rule? This says, do you know the product rule? Doesn't matter what the function is called. Could we call it pony of x? Sure. Doesn't matter what we call it. It acts the same way. F and G are just arbitrary labels. We tend to use F and G all the time. Should you be comfortable with any label? Absolutely. Typed it out. So we have F over G. So all we're using is we're applying the what definition? The limit definition of derivative. That's all we did here. Well, look. All we did, see the h right there? The h migrates out to front with 1 over h. So we have this thing right here. Let's see what we do next. Let's do some algebra here. Oh, what did I do? I took these two fractions and I made them 2 fractions into 1 fraction. To combine fractions, we need a. So all we've done so far is algebra, just with some nasty looking stuff. And we get this thing. Hey, what do you think's going to happen at this point? Take a guess. What did we do last time when we got to a step like this?
We added
Put
some
random
random
crap
stuff.
We added some random crap in it that didn't add anything because we added and subtracted the same thing. Look, we're going to add and subtract the same thing. Here's that center part, right? It factors nicely. We rewrite it. This looks terrible, but all it is just breaking things up until we get to things that are the actual derivatives of f and g. That's all we're doing. We're regrouping stuff so we get things that we can identify as the derivative of g and the derivative of f. You slog through this, blah, 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 and you end up with this right here. And it looks nasty, and it looks like something you don't have to memorize, but you have to memorize this. You will memorize it. You're going to use this hundreds of times. This right here is called the...
Quotient rule.
Yes, it is called the quotient rule. Make it nice and big for you. It's really easy to remember. You're not memorizing this, you're just remembering this.
For a second, I thought it was all together, like all of it.
F is over G. First of all, F is over G for this definition, okay? And all you really need to remember is the numerator. The way I remember that, you see it written in the book as GF prime minus FG prime. I remember it as F prime G minus G prime F. F prime G minus G prime F. Low D high minus, yeah, you got it, high D low. There's people that have put this to swing songs, like Heidi, 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 high, low. I can't do the song, I'm not going to do it, but low D high, what does that mean? The lower function times the derivative of the higher function minus the higher function times the derivative of the lower
I'm sorry, I'm
function.
cut off on the idea of you doing
Heidi, Heidi, high.
jazz song, like,
Swing song.
yeah,
And what's
D
the bottom?
kind of-
Low squared.
Low squared. That's all you need to remember. That's all you need to remember. So, before, if you had a quotient, you hope that you could simplify it down into a polynomial, right? You hope something canceled out. Does it matter if it cancels out anymore?
No.
Not so much. So if I asked you this question right here, like this one, can you cancel that out?
No.
No, there's no way to cancel anything out here. Nuh-uh. No way to cancel anything out. So in this case, the upper function. So if we do the derivative here, what's the lower function? Low, d high. What's the derivative of the top? Minus high, d low. What's the derivative of the bottom? All over. X cubed. That's not a 3. That's a weird new number. Minus 4 squared. If I just ask you for the derivative, you can stop there. If I just ask you for that proves to me you understand what you're supposed to do. If you were going to have to do more with this, it might be useful to do what to this?
Simplify.
Distribute, simplify, clean up the numerator, right? Maybe it'll clean up a little bit. But if I just ask you for the derivative, you can stop there. On the AP exam, if this was a multiple choice question, the multiple choice answers wouldn't be written like this. They would probably simplify it down, or maybe it simplifies and refactors. So they expect you to be able to do basic algebra after this. But at this point, Bill, sit up. Do you have to go any further? Is this the derivative?
Yeah.
Yes. Could you go further and maybe simplify this? Yes, you absolutely could.
X cubed minus 4 factor out of the bottom and top.
X cubed minus 4? No, there's no x cubed minus 4 up here.
Up left.
Yes, it's only in that one term, though.
Okay.
If you're going to factor it out of the numerator, you'd have to have it in here and in here. You don't have it in both of those things. So you can't factor it out of the top. Be careful. Do not do that. Don't survive calculus only to fall into the black hole of very, very poor algebra choices, okay? Please, please, please. The point. So to find the slope, what do we need to find first?
Slope.
The slope. Oh, sorry, we need to find the derivative. I'm saying the same thing over and over again. I'm sorry. So, what's the low function, Bissell? What's the lower function?
2x.
Nope. What is the lower function?
Oh. Plus
1 plus.
x squared.
Yep.
Oh.
What's the low d high? What's the derivative of the top fits?
Oh, EX.
E to the x. Minus high. What's the derivative of the bottom, Matt?
Remember the bottom is 2x.
Yeah. All over. 1 plus x squared.
Square.
Now, where are we going with this? We want to use this, and we want to evaluate this y prime at what x value? At 1. Do we need to simplify this first before we plug in a number?
No.
No. If you're figuring out a derivative just to evaluate it at a number, don't wade through the algebra of simplifying it, then plugging it in. Is it easier to plug in 1 and simplify, or to simplify and then plug in 1?
First one.
Put the number in first. It'll save you a lot of time, and it'll be a much safer maneuver for you. If we plug in 1 into this, what do we get? Oh, 1 plus
1.
times e to the
1.
minus e to the
1.
times
2.
all over 1 plus 1 squared. This equals 2e minus all over, which equals 0. So what's the slope of the line?
0.
So if the slope of the line is 0, there's the slope. And it's at that point 1e over 2. What's the equation of the line?
Y equals e over 2.
Excellent. Very good. What kind of line is that?
The horizontal.
Let's
line.
verify this graphically. Let's just see. Let's just see if the picture actually matches. So there's our function. And then our horizontal tangent. Is that kind of cool?
Yeah.
I think that's kind of cool. So don't freak out if you get horizontal lines. That's fine. I'm going to say this many, many times, but if you ever get stuck on the AP Calculus exam and you have some spare time, okay? So let's say you've skipped a problem, you've come back to it, and you have no idea what to do to it, but it gives you a function. Here's a really, really good thing to do. Take the derivative, set it equal to 0, and solve. That might help shake your memory up a little bit because you're going to do that so many times in this class on so many different types of questions. You're going to build a function, or the function is going to be given to you. You're going to take the derivative in one of many different ways. You're going to set it equal to
0.
and you're going to solve. You're going to do that so many times that you might as well just try it and see what happens, but only do that if you have time. Seriously, if you're totally lost, take the derivative and set it equal to 0. Seriously, just do that. Okay, moving on. That's nice. Let's say I gave you this one right here. Do this one by yourself. Given f is equal to that thing, find the derivative. Please use the quotient rule. But if I don't specify what method you should use, what should you do first on this? 2x to the what power?
Negative
Negative what?
3.
Negative
1/2.
negative 1/2. Thank you. So now what can you do?
Derivative.
Now you take the derivative. Do you need the quotient rule? Nope. 3 minus x to the negative 3/2. Is that a little cleaner than what you wrote down? It's actually, yeah, 3 minus that. Yeah, it's a little cleaner. So here's the lesson for this. Avoid the quotient rule if you can. Are you always going to be able to avoid it?
No.
No. When you're working with limits, what's the first thing you always check?
Can you plug in the number?
Can you actually just evaluate the function at the the limit you're approaching, right? With a derivative that is a quotient, does that automatically mean you must use the quotient rule?
No.
No.
Please, no, 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 no. Sometimes very, very bad things happen if you try to use the quotient rule. It explodes on your face, and it's not cool. You get burned. But if you simplify it first, is that a lot nicer than using the quotient rule?
Yeah.
Yeah, that is a lot nicer.